Hello and welcome to Python for Scientific Computing 1. My name is Venki Udameri. This playlist consists of a sequence of videos that are aimed to help you get started with using Python for scientific computing. It is geared towards students who are upper division students in engineering, particularly civil engineering. And the idea is to give you tools using Python to perform some routine mathematical tasks that you're expected to do uh, as a civil engineer. In this short video, I'm going to go over the learning objectives and some of the mechanics before we start with earnest into learning what Python is. So without further ado, let's jump right in and see what Python is all about. So what I'm going to do in this video is talk about this course. What is it about? Who does it target? Uh, why they should learn this material and how they can benefit from it. The broad goal is to help engineering students, particularly civil engineering students, started with Python programming language for use in their courses and projects. So before we get into Python, let me talk a little bit about the need for programming, why programming is an important skill for modern day civil engineers. As civil engineers or as engineers, you probably use a variety of different tools as part of your engineering practice. Clearly, there is CAD or the computer aided design software that you use to make drawings, engineering drawings. You use spreadsheets for routine calculations and charting, perhaps to store data as well. And then you're going to use some canned packages or discipline specific programs such as HECRAS, HMS in the water arena, or StatPro in the structures arena and such to perform some advanced design calculations or analysis calculations. It is also becoming more commonplace for civil engineering students to know some geographic information systems or GIS. And typically we use GUI or graphical user interface based GIS tools such as QGIS and ArcGIS. So typically these are standard software that students learn as part of their curriculum or throughout their curriculum. So adding some knowledge of programming can help your analysis with these tools. For example, you can take the output that's generated from many of your models and create better visualizations and charts and analysis and perform more detailed analysis than you could with simply the software. So that's where programming can help. Programming can also help you build either advanced models or simplified models that are routinely used to abstract out certain themes of your more complex analysis. So that is a very typical design exercise to create response functions or to perform sensitivity. And those types of things can be easily done using programming. Programming also has the biggest advantage in the sense that it helps you automate tasks that are tedious and routine. These tasks are not only boring for engineers, but also are prone to errors because we tend to get sloppy as we start working on the same set of calculations over and over again. So clearly, there are advantages of using a programming language instead of trying to do these things manually over and over again. Another very important and perhaps the biggest benefit for using Python or any other programming languages to perform your analysis is the learning that's associated with it. So when you use a canned package, typically everything is a black box. You provide some input, you get an output. You don't know what is happening behind the scenes. Whereas if you write a program, you have to write all that logic out. So it helps you think sequentially, helps you improve your computational thinking, helps you understand what is the logic, what are some of the steps that tend to be more critical or more complex than other steps, things like that. So that is the biggest benefit of doing some coding or doing some programming in addition to using all these software. So there are both advantages with respect to analysis, making your analysis shine, as well as improve your learning of the concepts using programming. So that's why I encourage students to have a programming skill in addition to the packages and the software that is discipline specific. So now that we have kind of established that programming is a useful skill, why do we want to use Python? Python is a general purpose programming language, so it is just like any other programming language. It is easier to learn than many other languages such as C, C++, because it operates at a much higher level using English-like syntax. It's a free and open source software, so unlike MATLAB, which is free perhaps when you're in school, but you may not have access to it when you go work in the industry, or ArcGIS, which tends to be available at universities, but not necessarily at many firms. You don't have to worry about not having access to this language. And also, more importantly, Python is widely used for scientific computing. So you will, there is already a large ecosystem of libraries and functions and work that people have done that you can simply reuse to make your life simpler and not having to reinvent the wheel. So those are some of the advantages of Python. One other thing that we are seeing, another trend that we are seeing, is that Python is often integrated with tools that civil engineers use. For example, Excel, Microsoft Excel, which is a spreadsheet, now has support for Python in addition to Visual Basic for applications. Similarly, many open source spreadsheets such as LibreOffice Calc also have support for Python. QGIS, ArcGIS, and other GIS tools offer Python support for automation and analysis. Same is true of certain CAD software. And Python by itself is a one-stop shop. So you can do GIS, you can do spreadsheet type work, you can do GIS, you can do statistics, you can do modeling, both data-driven modeling such as machine learning and artificial intelligence techniques, as well as traditional differential equations-based modeling, all within Python. So Python therefore has many benefits in comparison to other languages that are out there or compete with Python. Uh, Another big aspect in me picking Python is that Python is widely used, which means there is a lot of help out there on the web uh, to to help you out when you get stuck or don't know a syntax. Especially this happens because Python has a very large ecosystem um, of functions and tools. Generative AI tools such as ChatGPT can help you with coding, and it can write code snippets in Python. So this is another big advantage of using Python. And so we'll make use of these tools as and when necessary. And I'll also show you some of the benefits and some of the limitations of using generative AI for coding. So at the end of this course, what I want you as a student to know is remember some basic syntax of Python, statements like printf, like plot, and other things. Understand the various data types that you can store within Python and manipulate in Python. Understand and apply basic structural programming concepts such as conditional statements, if statements, else statements, as well as loops such as for loop and while loop. I'll also show you how to read tabular data into Python, create charts and visualization, and also we'll look at some common built-in libraries for engineering mathematics calculations. So in a sense, what I want you to be able to do at the end of this video series is to be able to use Python to do the math that's expected out of you as a civil engineering or an engineering student in upper division courses when you have junior or senior standing. In terms of Bloom's taxonomy, we are going to be focusing on the lower echelons of learning, namely remember, understand, and apply. I want you to recall some basic syntax, understand some of the programming logic, and apply it to engineering problems so you become comfortable with using Python. So before we delve into Python, I also want to quickly state what's the best way to learn Python. Clearly, the best way to learn Python or any other programming language is by writing code, getting your hands dirty, actually typing on the keyboard and trying to do certain things. Of course, this is not going to be an easy process, especially if you have never done programming before. But remember that reading or watching videos will do very little for your learning. It's also very important to remember that your code will likely not work the first time it's written. This is very normal. This happens to even me, who's been coding for almost 40 years now. It is fairly normal for that to happen. So you got to embrace this as a learning moment and learn from it rather than beat yourself up. You need to be patient and avoid taking shortcuts. So you need to be smart in looking for help on the web, making use of generative AI to help your learning. But using Gen AI to simply solve your problem does not always yield the best results, both in terms of learning and both in terms of the syntax that's needed. So use it as a guide. Don't make it the master to do your work or your slave to do your work. So with that, what I'll be doing is I'll be making use of a Python environment that's on the cloud. We'll be using Google Colaboratory. You can Google Colaboratory and it'll take you to colab.research.google.com. You need to have a Gmail account to sign in, and you can use one that you already have. It's a free service, so you can make use of the Python that's available. What Google Colab does is Google Colab has all the libraries and backend that you need for this course, so you don't need to worry about installing libraries or things not working. It's also platform independent, so you can run it from Mac, Linux, or even Windows. What Google Colab does is Google Colab uses Jupyter environment. Jupyter notebooks are notebooks that combine text, particularly HTML and LaTeX for putting mathematical equations and coding using Python programming language into an interactive notebook that you can then share or use for your purposes or store for your purposes. We'll also be making use of GitHub. GitHub is a repository for storing codes. You can create a free account in GitHub using go to www.github.com. And then you can upload your codes that you've written in the collaborative environment and save it on GitHub. And I'll show you how to do that as part of this as we get into this course. Some useful links. I will be using GitHub to post many of the materials for this video series. So things like the presentations that I've used, some self-study exercises and such for you to explore. In addition, if you look at the description box, there'll usually be a short quiz. This is done using Google Forms. It's completely anonymous. You can use it to test your understanding and see what portions of the video you probably need to rewatch or some concepts that you need to research more on. So with that introduction, I welcome you to the course. Happy learning, and I will see you in the next video. Till then, take care and stay safe. Goodbye.